So today I will introduce my power generator which I have made from all the old power bank batteries which were somehow either not working or gone wreck. So those were hell lot of batteries. Let's see. If you see, yeah, I have made 7.4 volt packs of the batteries in 3 packs and one 3.7 volt. These are in series and also parallel. We can see how many are in parallel. So 1 2 3 4 5 6 7 8 9 9 10,000 mAh power bank batteries are there, and 9p and 7s, so 7s 9p. And for that I'm using 7s BMS. Let's see. This is 7s 20 ampere BMS, which is connected in 7s configuration. These are all lithium ion batteries from the old power bank. And then I have one battery meter from Junk Tech, this model KL110F, and it has temperature sensor and the ampere meter connection. If you can see here, this is connected, and this all is connected with 2 wires in solar panel configuration, MC4 connectors, plus and minus. Oh no, this one is plus and this one is minus. And let's see how it works. I will connect the charger and we will see how it works. And before we see how it all works, we can see here the Junk Tech battery monitor. I will make a separate video. If you want, give me some comments, so I will make effort to make a good video on it. And let's see how it charges. And let's see how it is getting charged. So there is no load. Currently the MPPT is fixed at 27 volts, around 0.3 ampere or 6 ampere is coming, and the battery voltage is current 25.2 volt, and it is getting charged at around 0.6 ampere. Rest, there is no load. So it shows that the battery monitor is running. I will add a video at the end of this, how the different parameters are looking, and how much capacity does it have. Can be calculated very easily. There are altogether 7s, 9p is there, and each of the battery power bank battery was 10,000 mAh, 9 in parallel. It means 10 multiplied by 9 is 90 mAh, 90,000 I would say, multiplied by 7, so 630,000 mAh. And roughly in watt hours, so in calculation 90,000 multiplied by 7 is 630,000 mAh, which calculates something roughly to 2.2 kilowatt hours. Effectively I have measured, I get around 2.1 kilowatt, but as It is not a lithium LiFePO4, LiFePO4, possibly lithium iron phosphate batteries, but the lithium iron batteries, ion batteries. So it will work only for 1 or 2 years, not more than that. Let's see, but at least I have got to use the bad power banks. Oh, this is the interface for battery monitor. Let's connect it. This one is the address of the battery monitor. Oh. And we can see that there is low voltage protection. It's turned on. Let's switch it off. And now we can see that currently it is charging at 0.79 ampere, 17% is charged, and capacity left is 15.28, 15.3, charge at around 90-20 watts. But this is evening. What else does this battery monitor gives? It has the over voltage protection, low voltage protection at 23.5, over temperature protection it has, over current protection it has. It also has one relay up mode, relay mode. What else it can be shown? Currently temperature is 24 degrees elapsed. Currently it has used more than 750 ampere hour has been discharged from this. Can be cleared by clicking on the data cleared. And 21.26 kilowatt hour electricity has been stored and discharged from this battery pack. So I would say it is working good, in my opinion. If you have any questions, feel free to ask, and subscribe. And if you have liked it, you can like the video, and if you have not liked, then dislike it. But subscribe and like it and share it naturally. And if you have any questions, please ask. That's it. That's all for today. Thanks for watching. Bye bye.